Hello, and welcome to this webinar hosted by Tata Elxsi and Nelson Hall. And today we are going to talk about digital manufacturing with two of the leading experts on the panel. Allow me to quickly introduce Tata Elxsi. Tata Elxsi, in an elevator pitch, is a design agency which blends together technology, engineering, and creativity to deliver world class solutions, services, and experiences. The fabric which binds all this together is the digital piece today. And one of the aspects of the digital piece, which is digital manufacturing and the predictive framework, is what we are going to discuss here. So, on this panel with me, I have Aditya Chikori, who is the business head of Tata Elxsi, and along with him, is Dominic Raviart, who is the industry analyst representing Nelson Hall. Welcome, both of you. And if I could just ask both of you to give us a small intro about your journey, your professional careers, and connect the dots for us, please. Aditya, you may want to go in first.
Sure. Thanks, Sunil. Thank you so much for the initial introduction to Tata Elxsi. In a way, you have sort of created an expectation of where we are coming from. As far as I'm concerned, my name is Aditya Chikodi. I've been in the industry for close to 23 years. Most of this time, almost all the time I've spent with Tata Elxsi. I'm the general manager and head of our design, engineering, and visual extended reality practice, within which very closely we work with various manufacturers in consulting and working with them to implement the digital transformation strategies for manufacturing vertical specifically.
Thank you, Aditya. Dominic?
Thanks, Sunil. So my name is Dominic. I've been with Nelson Hall for about 24 years. My job is to evaluate offerings, compare offerings within different service providers, and and I've been working in this space, working on IoT initially and then digital manufacturing for the past 5 years or so. So that's me in a nutshell.
Wonderful. Thank you, both of you. And I think we're going to have a very interesting conversation. And I'm just thinking, with my 3 decades of experience together, we have about 75 man years of experience on this webcast today. Wonderful. So let's jump into the topic for today is predictive frameworks for digital manufacturing. Now, let's break down the whole pieces and come to the brass tack. What is digital manufacturing and what are its benefits? And I may ask Aditya, from where you come from with talking about digital transformation and other aspects, give us your view about what you think is digital manufacturing and their benefits.
Sure, Sonal. Thanks for that question. I guess that's the right question to start with because if I were to put it very broadly, digital manufacturing is the use of integrated computer systems, which comprises of simulation, 3D printing, collaboration, analysis, and various other such methods and processes for efficient manufacturing through digital thread. Now, what it basically is about a digital thread that is created all the way from design to production to the final product. And it brings together the product lifecycle management, smart factory, and value chain management. So if you look at the fact that it brings these three elements together, it clearly means that smart factories are by default not digital manufacturing, but today digital manufacturing and smart factories are being used synonymously. And when I say smart manufacturing, I'm basically alluding to the Internet of Things, which has entered into the industrial domain, and we call them the industrial Internet of Things, right? Which also means that we have had digital manufacturing to a certain extent as a practice, but which has been predominantly at the IT layer with all the systems and processes that exist today that integrates certain aspects of the supply chain into a level of integration into the manufacturing plant. And why are we discussing this? I think the answer is very straightforward and simple. As you get down to a better vendor management or supply chain management, as you integrate the entire product lifecycle management into the manufacturing process, supported by an integrated manufacturing plant or the shop floor, what you get is data. And with data, you can draw insights. And through insights, you can take better decisions, real-time decisions, leading to reduction in cost, uh, reduction in time to market, better utilization of resources. Let me take one example to just give you a sense of what we've done recently. We worked with an electronics manufacturer who was setting up their manufacturing plant here in the country, uh, and this is a greenfield project. And it was very important for the manufacturer to have an end-to-end visibility into the from the raw material to the end product, including the stages and steps associated with the new product development NPD process, design for manufacturing process. And at Tata Elxsi, we implemented a track and trace solution, which is a microservices architecture, which brought together various different machines that are making up this plant. And a record time of 6 to 7 months, we went from zero machines, zero production to more than 1,000 units, and now scaling up to more than tens of thousands of units in 12 months time frame, right? More importantly, the track and trace visibility was not limited to the plant, but the visibility was actually at the level of the end customer, and this had to be done in a very secure fashion. And what does this do? It allows both the end customer as well as the manufacturer to take certain decisions based on the global supply chain situation, based on the global demands, on how they want to configure the plant, uh, how they want to increase or ramp down on production, or reconfigure the plant for multiple different product lines. So I hope that, with that, I would say is why we are discussing digital manufacturing, and what could be the benefits.
Awesome. I think the electronics use case study that you talked about seems just the right recipe for the track and trace, Aditya. I'm going to quickly turn to Dominic for his two piece on what is digital manufacturing from a industry perspective, and where do you see the most impactful benefit, Dominic?
Thank you, Sunil. I guess the way we see digital manufacturing is as a next step in industrial IT software. With IoT and the newest technologies, just such as immersive technologies, AI, computer vision. I think we're seeing now a new technologies being deployed in a firm, in the plant or across the equipment. And the benefits of those new technologies are really one, centralization, trying to bring some level of standardization into a heterogeneous type of landscape. And the second one is a remote access. And that doesn't sound like a lot, but actually it's quite a revolution, we think, for the industrial plants. So as I would say, some level of standardization across the plant and remote access and actions. That's massive. And we've seen that benefit during the pandemic as well.
Wonderful. And I think the keywords I'm taking from what you guys said is integrated data and insights. We'll come back to those points again. Dominic, from an industry perspective, you are one of the leading analysts sitting there. Give us some quick sense of typical use cases of where digital manufacturing gives the maximum benefit or impact to the organizations.
Thank you. Okay, a fairly difficult question because there's a lot of creativity in this industry, and there are a lot of use cases. If I take a step back and think about three categories, the first one is going to be about around employees and workers. So a lot of safety concerns, especially in the pandemic, with social distancing, worker security, with, for example, detecting if workers are wearing their helmets, safety helmets. So worker productivity and safety is a very important one. Sort of derived from that is theft management and tracking objects and anything outputs from the production. The one I like the most is around training and SOP, standard operating procedures, thanks to immersive technologies. So my favorite example in this space is really about for a large manufacturing firm in Europe that is recreating Vertigo for its workers. And clearly, while that's quite exciting, the workers love it, and you could not recreate the Vertigo feeling in during a PowerPoint presentation. So that's, I find it amazing, to be honest. And the
Absolutely.
last one I like is it's really at the corner, at the intersection of workers and equipment use cases around remote assistance with an on-site technical expert and a remote expert who is specialized on the machine or the equipment or the assets. So again, well-known use cases, but this is where at the worker level or employee level, we're seeing the most activity. And then
Wonderful.
I think I touch on plant and equipment. One of the main use cases is monitoring, again, because in the past we didn't have this remote centralized access, dashboards to data, access to data. So that's the first step. And then in the future, not so far, we'll see more predictive algorithms and potentially simulation and digital twins. And then you've got more traditional consulting activities in digital manufacturing, such as process improvement, so more consulting-led, throughput optimization, consulting based on the data now that you've got available. And the one I like most for being implemented is really about quality inspection based on computer vision. That's quite exciting. That's a lot of productivity.
Wonderful, Dominic. Thank you for that. And I'm sure Aditya would agree because Aditya, we have personally driven initiatives on two of the things which are very close to your thing is worker safety and trainings. And Dominic did talk about extended reality. Do you want to quickly touch upon a couple of use cases that Dominic has spoken in theory, but you would have done in practical?
Absolutely. I think Dominic touched upon all the use cases that we are seeing being piloted, and more importantly, in the last 2 years of pandemic, many of these pilots have been taken into full blown production. One that we are seeing quite pervasively being explored is using immersive technologies like AR, to an extent XR, for MRO, that is maintenance, repair, and operations, especially by having the possibility of connecting with an expert sitting remotely in any part of the world, any geography, and
Sweet.
being available to both execute the job at hand, but also be able to maintain and sustain the machinery and plant. We worked very closely with an high-tech manufacturing, a semiconductor manufacturing company in Asia, in helping them digitize the SOP, standard operating procedures. Of course, see, the at the end of the day, it's an ecosystem in which we have to operate. There are device vendors, there are platform software providers, then there are application providers, and we as a system integrator and application developers are able to bring all these ecosystem partners together. So we work very closely with Lenovo, for instance, work very closely, very much on the Amazon or the Microsoft Azure platforms in order to realize some of these cases. Worker safety, absolutely. If I'm not wrong, today almost every organization is signed up for the Sustainable Development Goals Charter. Sustainability has become a need and necessity. It's no more a fad, but it's an hygiene factor. And out of the 19 SDG goals, one of the SDG goals focuses on the health and wellness of the individuals and workers. And our ability to ensure a safe, growing environment to the workers is going to be paramount. And I think that's where use of tools like AR, VR for not just managing one's job, but also upskilling individuals as we start looking at digital manufacturing, preparing individuals for the future, make them party to the growth rather than having them at the wayside, is going to be an important element of this whole transformation.
Wonderful. Thank you for that, Aditya. And since both of you stressed on integrated in your earlier responses, I'm going to integrate now Internet of Things into digital manufacturing. I may also put a caveat here that Internet of Things has now mushroomed into Internet of everything. Everything that we can think of, we see around us, is talking to each other. How do you guys think? And I may ask Aditya to go first, is how do you think the IoT is blending in with digital manufacturing? What are the kinds of investment in efforts and in commercials that are needed by organizations?
An excellent point, Sunil. And yeah, if you go back to the very first question and we spoke about digital manufacturing, I called out smart manufacturing, and somewhere I said digital manufacturing and industrial Internet of Things, IIoT as it's called in this industry, are being used synonymously. Uh, See, the why is Internet of Things so important? It's human machine interface has been there for ages. Machines have connected. We've been able to read data out of machines, and we've been able to do something out of these machines. But with each machine having its own format to talk and communicate, that becomes an onerous job to have some sort of a framework in which this data is collected. Internet or industrial Internet of Things is a mechanism in which you are basically now creating a common template using which all the machines in the manufacturing plant are able to communicate with using the same protocol or language, which then allows data to be aggregated and thereby allowing from our ability to visualize data, to act on the data using some modeling, so predictive or preventive modeling, to taking certain decisions that can either be real time or can be real time for the plant, and also in terms of supply chain integration and management. More importantly, if you follow the whole IIoT or industry 4.0 revolution, they're built on six odd principles. Yeah, these principles translate to interoperability. That's what I explained. Decentralization or democratization is where, because it's standard, data is available. Now you can have the data visible at the shop floor level as well as the central level, right? Now, since it's a standard protocol, you can also it becomes modular in nature. You can reconfigure the way these machines are connected, interconnected to form different types of lines or pods based on the supply and demand requirements. Data is available in real time, which means that you can do a lot of things with this data. And also, and here's the clincher, you can actually virtualize the whole thing, right? You can actually create an equivalent of what's going on in the plant, be it around the plant, be it around the process or the product, and be able to study the impact of this. For example, we have worked with customers in reconfiguring their plant to introduce robots into the plant, but allow an human and robot integration and interfacing for efficient manufacturing. When you do something like this, in addition to looking at the process, you also need to look at how these individuals would be placed, which is safe as well as productive, thereby targeting an increase in the OPR or the OLE and OE parameters. For one of our customers, where we landed up doing this, we could achieve, if I'm not wrong, somewhere close to about 30% improvement in the operating parameters, and the line efficiency went up by close to about 78 percentage points,
Wow,
right?
wonderful. I think it's a very interesting trend that we are seeing, and I'm a little scared, guys, that are humans going to get more smarter or machines going to get smarter? So maybe some other webinar we'll keep that as a conversation. Now, let me bring another interesting technology into the conversation, which is digital twins. I think there is a lot of noise and talk that hear in the industry, in the customer's place, in the vendor's place. So here is a question, and I may ask Dominic to lead this: that how is digital twins transforming the manufacturing operations, be it smart, be it conventional, and how is the impact of this digital twins going to facilitate what we commonly call as DFM, design for manufacturing? Some thoughts on that, Dominic?
Thank you, Sunil. So, I'm sorry. Yeah, I think the concept of digital twins has a lot of potential. So at the moment, it's more than a concept. If we look into the actual implementations, we find most of the activity those days around monitoring, so collecting data from various sources, whether it's from the equipment, from the PLCs, from the SCADAs, and so forth. So that's expanding through sensors, obviously, complementing the equipment. And also now we're seeing integration of data from the various applications, so mostly the ERPs and the MES. So that's where we're seeing most of the activity, and that's quite a lot actually, because again, we're now able to access data remotely, which we couldn't a few years ago. So that's from the high level concept, but that's already one giant step, and that we welcome that. Along with this, more exhaustive dashboard and remote dashboard we now have, most of the activities also shifting towards 3D models and having a view of the equipment or the process or the machines or the plant in the best cases. And again, that's a major step. Again, in the times of so much attention about employee acceptance, UX, having this 3D model is also a giant step because it helps viewing where the problem is. So not just numbers, but also a wider understanding. Again, we're fairly far away from the future state of digital twins, but that's already one good step. And the way we see the future really for around digital twins is going to be around simulation. So simulation is easier said than done. If you look into simulation and the current projects, now for equipment that is software centric, we think for reverse engineering, it's quite possible to recreate the behavior of a piece of equipment. We're not yet there at the process level. And for different type of equipment, this can be more complicated than huge specialized software. So let's be cautious, but this is where what the state of the art is actually currently, and that's quite impressive already.
Wonderful, Dominic. And Aditya, from a field perspective, you engage with so many organizations, so many CXOs. What are your quick thoughts on how digital twin is impacting this from a practical perspective?
Right. No, I second what Dominic has pointed out in context of where digital twins are and how they're evolving from being dashboards to a more integrated solution. And again, this goes back to the fact that we have been talking about industrial IoT, right? And we are talking about data. We are talking about creating an equivalent of physical in the digital environment. Now, why are we doing all of this? Our ability to not just visualize, but ability to also use the data that is coming in real time from an product or a process or a plant allows us to do certain experiments, and those experiments are useful in taking certain actions that can improve the overall efficiency and productivity. We have been working with customers, for example, in the context of sustainability and circularity, and we worked with one of the pharma companies where we went ahead and developed a digital equivalent of an nasal rocket. On one hand, reduce the plastic usage in the product, but at the same time make the product more user friendly. Now, we did this at two stages. One, we applied the principles of digital simulation right at the beginning of the design phase itself. Sunil, I remember you somewhere in the question also had, how does this relate to design for manufacturability, right?
That's
and when
right.
you look at it, that the whole idea of design for manufacturability is basically a process that will help in the manufacturing process, such that it reduces the resources that are utilized, that reduces the kind of material that goes into the product development. It improves efficiency, it reduces the time to market, it brings value in the entire value chain to the end customer, right? So we went through the process of looking at doing a benchmark analysis, running CAE simulations and CFD simulations, looking at the various material compositions, and then coming out with a nasal spray that is pipette based with a force equivalent to the force that's required to press the spray. You would have the right amount of dosage that is sprayed into the nose. The next stage would be to take this and have some sort of sensorization built into it, which will allow real-time utilities to also be fed back. And that would be the ultimate goal of a digital twin.
Wonderful.
We have, if I may just add one more, we have done sort of a digital twin at a plant level, where we have tried to recreate a plant, take the plant CAD model, take the machine data model, and then looking at the OPR, OE, OLE targets of the customer, come out with the line configuration, which includes robots as well as human beings, the workers, for the target efficiency, and how the entire material is going to move from one machine to another machine in the process, and at what rate these components are going to be processed, including points of integration where certain components might be picked up for quality assessment. So integrating it with the equivalent of quality engine for the component, processing, like a PQ web or something like that, right?
Thank you, Aditya, for that input. I think it's quite interesting, and I hope the digital twin story picks up a little more tempo for making our lives a little better. You both will agree that, in a way, I felt when both of you were talking as if you both are digital twins for each other. It's in the context of the subject that I was talking. So let's go down to the path of this world around us is degenerating so fast. Everywhere we have pollution, and hence there is a great amount of focus that is coming on reducing the carbon footprint, making it green. It brings up the big subject of sustainability. How do you guys think, and I may ask Aditya to go first here, that the predictive methods which are from the emerging technology aspects, how will they help us into going towards sustainable manufacturing?
Sure. So first, I would just like to take a few seconds or a minute to talk about, because you used two words out here, or rather three words. One was sustainability, and the other two are sustainable manufacturing. Sustainability can be part of sustainable manufacturing, but sustainable manufacturing is a much more broader terminology. And sustainable manufacturing is predominantly do with a regenerative model that feeds the facility of manufacturing. So if you look at the whole impact of manufacturing, which is due to the energy usage, natural resources like water, air, and the environment around us, the emissions that they generate, the noise that they generate, the waste that they generate, right? And the whole idea of sustainable manufacturing is to reduce the impact on the environment by either reducing the usage of these natural resources or regenerate them, right? Reduce the waste that is generated, or have a way of repurposing the waste that is brought back into the system.
Correct.
Now, when you look at this, and then we talk about sustainability and then predictive models, so this has to be applied across the entire product life cycle. And if I go back to the example that I took of the nasal spray, and I spoke about design for manufacturing, and I spoke about how we had to look at a design that would reduce the overall impact on the environment, for which we had to go all the way into the supply chain as much as the design, but we also had to look at the raw material associated with it. We also have to take into account what are the resources, how much of resource would be required in order to generate convert a design of this nature into a manufactured product. And when we look at the manufactured product, we need to then look at how the whole, if there's any waste is generated, can that be recycled? So hence we start talking about circularity. But we also need to look at the design in such a way that the design is not one time, there's an end of life that is going to put this into the landfill, but is there a way to reduce, which I spoke about? Is there a way to reuse? Once the natural life of the product is done, is there a way to reuse, circular it back? Or is there a way to recycle this? Maybe the product comes back, and then there are different business models associated with it. So simply put it, sustainable manufacturing, thereby an impact on sustainability, is going to get influenced by product design, is going to get influenced by process design, is going to get influenced by operational principles. Now, if you are able to collect data at the plant level of energy consumption, of resource consumption, if you are able to collect data at various touch points of the design process, this data allows you to you can mine the data, you can see patterns, you can create predictive models, and you can also come out with proactive models of how to reduce waste, how to improve efficiency, how to improve productivity, what sort of, if integrated back in the supply chain, where are the carbon footprint points that the data is pointing out to, and how can you work with your suppliers in order to reduce the overall impact on the in the value chain. I think these are certain examples. So when we look at I would say we are looking more from a sustainability point of view from where we come, but we apply the principle, the processes of the life cycle assessment or hot spotting, benchmarking in our product design and process design processes activities, and then apply those principles in the design of a product. We are also working with the customers in the upstream, which is downstream, which is also see are there innovative business models that can be introduced, which can recycle the products back into the system.
Wonderful. I think feeling a little confident, and I'm sure for the listeners on this webcast and people who are with us, Tata Elxsi, your design studio, Aditya, will be the best place to showcase the sustainable product design packaging that I'm aware that we guys are doing. Brings me to the next question that we've gone through digital manufacturing, the fundamentals, the IoT, and the digital twins, sustainability. The last, but not the complete piece, is that what would be a typical roadblocks that an organization should plan to mitigate when implementing digital manufacturing, Aditya, from a from a field perspective, from an engagement perspective? What is your experience on that?
Sure. See, I would not call them roadblocks. I would rather call them an step towards evolving into a fully digital manufacturing. And if you look at it, there could be about 5 or 6 stages in which an organization would go through as they look at adopting digital technologies in the manufacturing process. The bare minimum is what is happening today in many of the MSMEs and some of the larger companies is automation. And automation is not about removing people and adding robots, but it's about our ability to connect all the machines, connect all the processes, and get a democratized single view of data, right? So it starts from the level of automation. Once you have this level, then it is visibility, because once you have data, you have visibility, and data is coming not just from the machines. Now, if I might use terminologies out here, I would say the ET, that's the embedded side, the operating side, and the information technology side, right? So now you have data that's coming and there's visibility, wherein I go back to my track and trace example, that work that I was talking about. Once you have this visibility, you can, with this data which is coming, you can create models, you can do some experimentation, you can uh, do predictive or preventive algorithms. And based on the nature of data, you could also use, as Dominic had alluded to, if the data is in form of video, you could also use this data to do different types of quality inspection, end of life validation, tracking of man and material within the facility, right? So with that, you can come out with better compliance, better production monitoring, and productivity monitoring. And with that, predictability comes into place. Automatically, there's a better management of resources, remote operations, and the true transformation is when you are able to address supply chain resiliency, and that's one of the biggest challenges. Now, these are stages, and these stages are going to be based on the business objectives. They're going to be functional objectives, and there will be operational goals. So any organization that is embarking and manufacturers embarking will have to decide on what are the prime business goals that they want to target, right? Based on those goals, what are those functional KPIs that they might want to address? For example, is it a supply chain integration? Is it learning and development? Is it worker welfare and well-being, right? Whether it has to do with quality management. And then what are the operational goals? Not just the revenue and the profitability, but the productivity parameters, OPR parameters, OE parameters, OLE parameters. We've been working with, so this requires support from management. And this has to be addressed. There has to be a buy-in at the CXO level there, because they are the ones who should have clarity in what their end goal from the digital transformation is. And then that whole thing has to percolate down to the node, which is at the plant level. So I think these two have to get bridged and integrated. That's why I said I don't think there are roadblocks. I would rather say that if the business goals and objectives are clear, you know what functional goals you want to achieve and what are the operational KPIs, and then you phase it out. It can be in the automation through transformation, or it could be phase 1, phase 2, which could be agile models of packets of these. one point, one point, sorry, I wanted to add here, and now I would say the roadblock, right, is what happened 2 years ago is that Industry 4.0 revolution has started back in 2007, 2008, and 2000, between 2011 to 13, we saw Germany really ratifying it as a standard. But most of the organizations who went down that path outside of Germany, they had multiples of pilots. And like one of my colleagues says, we are running pilot purgatory. It's like pilots after pilots after pilots running in silos, running in various parts of the organization. And unfortunately, you don't see these converging. So roadblock is once you know your objectives, once you know your functional goals, when you know operational KPIs, it's to ensure that you avoid running pilots. Rather, you run programs for scale. And how do you achieve that goal?
Wonderful. I think pilot purgatory is something that will remain with us, Aditya. Thank you for that. It was a lovely explanation of breaking down the whole piece into the five broad steps of evolving the whole framework into digital transformation. At this juncture, I'm going to ask our industry expert, Dominic, to add to, do you compliment with Aditya on the steps into evolving this? What is your experience and take on the subject?
Thank you, Sunil, and thanks, Aditya, for this concept of pilot purgatory. I also like it a lot, so thanks for this. So I think, like in any digital transformation projects or program, we tend to see those projects or programs led by the top with executive sponsorship, and that's clearly needed. So we need top-down type of projects and programs because it makes things go forward. Now, with diversity of plants and their autonomy and also their different type of equipments and specificity, we think, along with this top-down approach, we need the bottom-up approach. And I think that's no surprise that Toyota promoted this approach decades ago. So we need to align and combine those 2 point activities, or should say approaches, together. And a lot of the digital transformation can be at a granular level, at the plant level or the equipment level or the team level. Now the challenge is to avoid fragmentation of technologies, fragmentation of projects. And I think the Indian industry has done an excellent job is promoting this notion of COE, so Center of Excellence, promoting tools, common standards, common tools, common processes. And I think that COE structure is perfect for driving, aligning, coordinating the initiatives at the bottom level, at the plant level. So I think a combination of top-down and bottom-up are wonderful. Top-down needs to be obviously sponsored at executive level, but bottom will really the willingness of the employees, and that's also very important. So it's a wonderful organizational change management tool, to be honest.
Wonderful. And I think I couldn't just make a comment that I think the success of the digital manufacturing would mean all hands on deck across an organization in their own capacity. Then that brings me to the last question on this webinar, which is, we've seen the evolution in the last few years. We all know where we are with digital manufacturing today. Let's do some crystal ball grazing and say what's going to be the future. I would expect you guys to keep it short term because we don't know what's the long term future. So, in the short term, where do you think is this future for digital manufacturing headed? Let's have the industry view first, Dominic.
Thank you, Sunil. Again, Aditya has done an excellent job is bringing the business importance to digital manufacturing to the use cases. So yes, the future of digital manufacturing is around the use cases and the benefits for the client, but we need to acknowledge that it's also technology driven, and there are a number of technologies like 5G, blockchain, AI, and machine learning and computer vision, drones and additive manufacturing that are adding a lot of use cases. So let me take a couple of examples. With 5G, we're probably going to go the path of low latency, and that's going to be very useful for controlling autonomous AGVs, vehicles, whatever you call them. So that's one, and that's looking in the future in the next 5 years or so. Additive manufacturing, we thought that was going to be game changer. Not yet, but with things, 3D printing for spare parts, combined with blockchain, does solve the long-lasting issues of IP and property rights and patents around spare parts. So I think that's the next step. And last example I like the most is there is this aircraft manufacturer that uses drones combined with visual inspection, so computer vision, to inspect the aircrafts and see if there is any paint detection or deterioration. To me, that's the future, and that now needs to be rolled out within the civil industry. So yeah, these are my my views about the future.
Wonderful. And if I could ask the industry captain from the field perspective, Aditya, what do you think is the future and where are we headed?
I think the future is everything that Dominic has said, and it is our job to make sure that the future is realizable by bringing the right capabilities and competencies. Uh, Rightly said, all these technologies are important, relevant. At the same time, not all these technologies need to be implemented in one go. So the technology-led strategy needs to have a business perspective, and the business should, based on the use case, dependent on the business, the combinations of technologies would come and sit together. For this, organizations will need to work in an ecosystem of partners, from device manufacturers to software vendors to application vendors, to bring all this ecosystem together. So everything that Dominic said holds true in an integrated fashion. And I would say that, I wouldn't say crystal ball gazing, but I guess digital manufacturing future is a time when, based on the supply and demand requirements, the plant can get reconfigured in real time to meet the demands of a design that was done by somebody sitting in some nook and corner of the world, and the plants become manufacturing as a service more than a manufacturing for a particular product or two products or a few defined products. I think that was where you would really see the whole industry 4.0 revolution. In fact, if I'm not wrong, people have started talking about industry 5.0 also. So I'm a little concerned and worried as to what that would be for. That's for a different day.
Sure, sure. Appreciate very much, Aditya. And if one has to take a look at all that we spoke, what would be your guidance on that to the viewers?
Digital manufacturing is here to stay. Digital transformation is going to happen. It's just a matter of time. What's most important is that it's not a man versus machine or automation versus no automation question. It's more of how do you leverage the combination of technologies and the associated principles to deliver on the priorities the organization has. While doing so, it's very important to also remember that humans are going to play a critical role in this. It's just that the capabilities and skills required are evolving. We are expected to have a very massive shortfall of experienced hands, and that's why one or few of these technologies will have to be implemented to also upskill, cross-skill the workers alike in order to be part of this growth, and hence evolve into a much more sustainable, sustained, I would say, a workforce or an environment.
Wonderful. Thank you so much, both of you. I think it has been a wonderful time that we spent on understanding this subject. Uh, Before I open this webinar for question and answers, Aditya, you want to talk about the conference which is coming up very soon?
Absolutely, Sunil, and thanks for reminding me about that. Uh, all that we have spoken today, and thanks so much, Dominic, for your views and insights that is brought from the industry. I'm sure this is as a result of discussing, talking to, and helping many companies implement or transform their journey towards a fully digital manufacturer. Uh, all that we have discussed, spoken, we would be showcasing a few of these in the coming manufacturing event at Hanover. It's called Hanover BC. It's in Germany. We'll be there from the 30th of May to the 2nd of June. and we'll be able to talk to you about everything that we're doing in track and trace, use of video and image analytics or vision analytics or vision AIML for quality monitoring, for safety, as well as training, as well as the work that we're doing on AR VR from MRO perspective to L&D. Our subject matters experts will also be on the ground to take any questions, walk you through our capabilities, and also discuss use cases that might be interesting and relevant to you. So
Thank
please
you.
do visit us. We are at our Mise. Yeah.
Wonderful. So that's for the viewers, digital manufacturing in live action, not in the distant future, but right across 1 week from now. Thank you so much, Dominic, for spending your time with us. And thank you, Aditya. If I could just ask both of you to be on the call to just address any question and answers as we open up this webinar to Q&A from our participants. Thank you.
Oh, absolutely.
Thank
Thank you.
you.
So we do have a question, guys, and this is from an automotive sector company. Uh, they say that there are many platform-based solutions for a lot of digital-based solutions like predictive analytics, digital twins, etc. They want to know some guidance about what are the aspects and criteria while choosing amongst the big congregation of service providers. Aditya, I think this could be uh, down your path.
Yeah, thanks, Sunil. Um, I think the question is quite pertinent. Like we have discussed over the last 45 minutes, thanks to Dominique for highlighting the various technologies together that determines the extent of transformation that an organization can embark, especially manufacturing per se. And it does create that much more that I would say is a challenge to decide which of the technology to pick up and how do you get started. Now, I think the question, if from there, if I try and elaborate a little bit more around the question that was asked, Sunil, if I'm not wrong, just to paraphrase, what I heard is platforms, then I heard predictive analytics, and I heard digital twin, and I heard the predictive analytics and digital twin as two separate items from the
Um,
question's perspective.
no, let me. So the question is that there are too many platform-based solutions which provide all these kinds of services or solutions. The question seems to be more that between everybody coming in, what should be the criteria that I should be looking at, and how do I select the right guy to go with?
Correct. Okay. See, there are quite a lot of platforms out there, which is the right statement. Like we have discussed in the conversation so far, the organization first needs to define their business goals. And there has to be an agreement that the transformation is a need, a necessity based on the business goals. And hence, there are certain use cases that they're going to prioritize. Those use cases are then going to get translated, and these use cases are going to get measured based on certain operational and functional KPIs. Now, when the organization looks at its problem statement, they will then need to evaluate the various platforms that are available. While there has been an effort made to sort of create a standard platform, no two manufacturers are the same. So far that they use the same set of equipments, they are the same, but beyond that, the way these plants are architected, the way the lines are set up, the kind of products they manufacture, even if the products they are manufacturing are of the similar nature, they are going to be different processes or process optimization that these manufacturers are going to bring in, right? And again, when it goes into the IT layer, there's going to be different set of priorities that they're going to have. So uh, it is very important that either the organization enrolls industry experts like Dominique, or the implementation experts, SI experts like us, who have done a few of these programs, so wherein we do get in to do what I would say the first stage is assets analysis. And assets analysis is basically to determine where the manufacturer is today, what are the business goals, and hence to achieve those business goals, what are those stages and steps that the manufacturer will need to go through. In that process, we then also analyze who are the potential partners, the sensor partners, the networking partners, the platform software partners. And these could, these partners provide solutions at the ET layer, that is the machine connectivity layer. Then you have the operating layer, which is to bring in the MES or the MOM if required, or some uh, proprietary implementation if that makes sense. Then also a decision on how far in the cloud are we going to go, whether it's going to be a private or a public cloud. And then the northbound integration into the overall IT infrastructure of the customer, right? So this analysis leads to certain suggestions. Then those suggestions will be evaluated based on the ROI expectations of the customer. This is where, to borrow from Dominic, technologies like, do we need an AGV or an AFV, right? Do we need to bring in AR/VR for some of the predictive, I wouldn't say maintenance, the predictive maintenance, but at least the MRO, the maintenance, repair, and operational aspects, right? What level of predictive analytics that we want to perform, and for what sort of operations, right? So things of these nature are going to get questioned, they are going to get answered. And based on that, based on a collective feedback with the leadership of the manufacturer, the suppliers of the platform would then get evaluated against that RFQ or the criteria that would be created. And hence, I gave a long answer, but the shortest answer now coming is, uh, it's not one size fits all. There has to be a consulting exercise done, because you manufacturers would already have some systems in place, and then we need to evaluate whether those systems are good enough and what extra delta would be required. And then we need to plan a phased approach. I repeat, it has to be phased out. If we go with a big bang theory, we have noticed in many cases that the euphoria with which the program starts, it sees a very early death. And all the investments that are made, unfortunately, tend not to generate the return on investment, and leads to a lot of negative perception around the digital transformation. And it then leads to delays, which affects the organization's future, I would say, the future plans and strategies.
So thank you for that, Aditya. And I think it's easier said than done. You tried giving us a straight answer, but I think it's more challenging for an organization at the customer end or at the receiving end. And you got these so many vendors. It's like, you got to go and buy a dress, and there are these hundreds of stores and boutiques which sell you the same thing. And I know it. I understand fully with what you say. There's a second question, and I think it's a very interesting piece of somebody asking that: is cloud technology a must for digital manufacturing? And I would ask my industry analyst friend Dominic to address this, because we did talk about IoT being blended into digital manufacturing in the conversation. I think it needs a bit of a clarification, Dominic, as to how is cloud technology integral part or a prerequisite for digital manufacturing?
Thank you, Sunil. Again, couple of thoughts here. At the data level, yes, cloud computing is sort of a choice by default. So I haven't seen any. Well, most clients are comfortable with storing their data on the cloud from a cost perspective. Having said that, cloud is not always an option for bandwidth reasons. Because of remote locations. So my favorite example in the most in the industry is really about a mining firm that doesn't have any connectivity. And then there are few regulations around data. You've got security as well. That can be an issue, especially for equipment that was not designed with connectivity and security in its core. So yes, at the data level, yes, but it depends really on the client, regulation and security and bandwidth access and so forth. At the application level, for the IoT platforms in particular, that's again a choice by default. I think we're AWS, Azure have emerged as strong contenders in this space, and certainly they're investing into their applications and platforms. But again, then you got the regulatory topics. So again, there you go. That's a yes, but depends. And sometimes we include MES in the conversation of MES, manufacturing execution system, in the conversation of digital manufacturing. And to be honest, while there are new offerings in this space, we haven't seen that much of a cycle of investment into cloud MES at this point. So hopefully a somewhat comprehensive response considering the time we've got left.
Thank you so much. And I think we will pause here and for paucity of time. And I'm sure when we circulate this, anybody who has questions will come back to us and we'll certainly take inputs from both of you. It was wonderful to have both of you on this panel. And we deeply appreciate you coming forward and sharing your insights and spending your time with us. And I'm hoping our viewers on this webinar have benefited immensely. Thank you so much, Dominic, and thank you, Aditya.
Thank
Thanks,
you,
Sonal.
Sunil. Thanks,
Bye.
Aditya. And thanks, everyone.
Thanks, Dominic. Thanks, everyone. Bye.